Well, hello, and welcome back. I'm AJ O'Neill, and I will be your instructor for tonight's Beyond Code Live. So tonight we're going to talk about paper programming and the Goblet of Fire. So the backstory on this is paper programming is a technique known by different names. Some might call it pencil programming or thinking on paper, but paper programming is kind of the term I like to use. But it's a technique that is recommended for people who are beginning programming and all of the FAANG companies, meaning Facebook, Apple, Amazon, Netflix, Google. If you go to interview for them, they'll give you a sheet of materials that says, here's the kind of things that you should prep for. And they'll give you some practice quizzes on things like binary search and whatnot. But one of the tips they give is that you should practice paper programming because the interviewer is going to ask you to think out loud and talk about your experience. And also it just helps you to be better organized. It makes you a better programmer. And we're going to go into why that is using a problem that Quadruple Digit, who is a person that attends a local meetup and on Twitter by that name, he presented last night this idea of using mnemonics, which I think it's actually supposed to be pronounced. I don't know how to say the word, but mnemonics. Anyway, brain hacks. He was talking about how to use mental brain hacks to remember programming concepts better, and he gave Goblet of Fire as an example. And so I will eventually link to that video in the description here once I've uploaded it. But I am going to kind of take his idea and mesh it with this paper programming idea. So if at any point, first of all, make sure you go to gist.github.com, bring that up so that you can paper program along with me and take any notes so that you can add them to your blog. And if at any point you have that aha moment, go ahead and give this a thumbs up and leave a comment with whatever your aha was. So with that out of the way, here we are looking at our terminal, and instead of having a code file, I have an empty notes file. Now, no self-respecting programmer would actually use a TXT file. We'd want to use Markdown. Actually, I use TXT all the time. But for this instance, I actually will use Markdown. But I do take just notes in plain TXT and then convert them later if I need to turn them into a README or something. But what we're going to think about, because the biggest problem is not, it's not how do I program this. So many people say, oh, I don't know how to program this in Python. Well, I don't know how to program this in JavaScript. And the question is, do you know how to program it in English or whatever your native language is? Can you program it in your native language? And the tools that you need to program in your native language are basically words like if, else, for each. Yeah, that's about it. That's what you need, mostly. So let's consider the Harry Potter Goblet of Fire. It is, for those of you that don't know, it is a magical trinket, and it has a job. So we need to think about what the rules are, and we need to think about what the rules are of the Goblet of Fire. So I'll explain it a little bit to you, and I want you to write these down before I do while I'm explaining it, and then I'll write them down. So the Goblet of Fire has essentially a job to do where every so many years, students from the different schools of the magical realms write their name on a piece of paper and they put it into the goblet, and the goblet selects one student from each school and then will spit those names back out, and all the rest of the names are disposed of or rejected or something. I don't remember exactly what happens. And there are some additional rules, but let's just think through, no, I'll go ahead and give you the additional rules. So the additional rules are that only participating schools, only students from participating schools can put their name in the goblet, and only students that are over the age of 17 can put their name in the goblet. So if these criteria are not met, then the goblet is supposed to just outright reject and spit the names from the piece of paper back out. So if we were going to program, let's say that we're making a video game where that's an online game and people can approach the Goblet of Fire. How might our program decide whether or not someone can put their name in, and how will we know when it's done its job? So let's just think about this in English. So we have the Goblet of Fire. So let's say rules for Goblet of Fire. And let's just put these down. So one of the rules is well, let's maybe not say rules as much as conditions. Let's just take some notes and then we'll organize it. Conditions for Goblet of Fire. There is a set of approved schools. A student from each school will be selected. Any student over 17 can put their name in the goblet. So we want to put, and then there's some sort of time constraint as well. Entries must be made, let's just say, in 5 minutes. This is not the case, but we'll just, so we can put something down there. So if I was going to program a goblet, I would have students. I would have student objects. I would have a goblet object. I would have some paper objects. So paper with names and ages, which I guess is essentially students. So what might I do? Let's say that there is a number of students who want to participate. So let's start with that. Let's just say that we have an array. Well, oops, sorry, I'm not programming. I'm just thinking out loud. So we'll call this participating students. What do we want to do with participating students? Let's say for each participating student, or actually we can do a little bit better. Let's say for each student of the participating students, write name on paper, write age on paper, put paper into goblet. So how the students decide that they're going to participate is out of scope. And we actually don't need to write the name on paper. We're just going to say, or we don't need to write the age on paper. We're just going to say, write the name. Now, once this process is complete, we might also want to say something to the effect of, if the call for entries is still open, or if the call for entries has closed, stop. And then we say else. Yeah, let's say like this. If the call for entries has closed, stop. Otherwise sounds more natural. Let's say otherwise instead of else. Otherwise, write name on paper, put paper in goblet. Okay, I think this is pretty well describes the situation. And then let's think about it a little bit more. That's from the student side. Now let's think about it from the goblet side. So we need to first define when this is going to happen. So we could say, we'll also allow some words that are colloquial English words like while and until, some time words. So until, this is what the goblet is doing. So students can have their own thing. They're operating independently. And then we'll say until deadline, if student, now let's see, until deadline, we will accept entries. So, yeah, accept entries until deadline. Yeah, that's what the goblet's going to be doing. So for each paper submitted, if, let's say, not if, but get student record for name on paper. And then we can say if student is younger than 17, reject. Otherwise, what will we do? We're going to, I think that's the major thing. Let's see. Let's say this. Or if student school is not in school list. All right. Yeah, we can just do like this. If students younger than 17, or if school is not in approved school list, reject. Okay, so we've got that done. Now, what else is this doing? So that's for each paper submitted, reject. So if we're not rejecting, then here we have otherwise. We want to accept. All right. Then we need a condition when the deadline is met. So let's say when, well, actually right here, we could say, okay, we're accepting entries until the deadline. So if we're not accepting entries, we could say otherwise, we're going to pick entries, because that means that it's the deadline. Either we're accepting entries or we're going to pick entries. And so here, we basically want to find a way to pick a student at random. We might actually do this. For each school, let's see. Here, we might want to have inside of the goblet 3 sections, one for each school. So let's say accept student into school into students school pile. So maybe the goblet first creates some pile for the students. Okay, so otherwise, for each pile of school students, we will shuffle the pile, pick a student's paper at random, and then I think we need to put we need to say spit out chosen paper. Here we go. So this, I think that's about right. I think if we follow these steps, if we were to give these steps to someone, now this isn't perfect English, but we could, I'm doing this maybe a little bit too much programmer style for what I was intending here, but I hope that you get the basic concept and the idea is that we're going through and we just need to think about it in English. Think about how to declare something very properly in English. And now let's clean this up a little bit. Let's try to make this like a program. So if I had a program, I'd basically have a button. And so if this was an online game, somebody would come up and they would say, they'd click on their mouse, an object, and the object would receive a button press. So maybe they click on the paper to grab it or something, and they click on the goblet to put it in. And so we need some sort of function that accepts papers for the goblet, and we'd need a way to put some sort of timer in here. But the important part is that we have a way that we can go through in our native language and just get it mostly right there. and then see how we could translate it over. So I'm gonna translate this over to code now, real quick. So we're going to say function submit. I'm just going to translate this whole function into code. What is this? So we're going to take students that were somehow selected beforehand, and we'll do students.forEach. And then what do we need to do? Well, actually, we can just, we could actually do this first. Let's see if, and then somewhere we would have deadline, if deadline return. So we don't actually have to do that for each student. We can do that beforehand. But we could do students for each, say student here, if student dot, and this might actually be names. Well, no, the student is submitting names. Okay, so if we just say student dot name, and we want to put the goblet, put it in the goblet. So we might have a function that is, I don't know what we'd call this. We'll call the function put in goblet. There we go. Student name. So for each student of participating students, if the call for entries is closed, stop. Otherwise, write name on paper, put paper into goblet. So maybe we actually want to do, there's a paper object and paper has the name, and we're going to put on student.name. That might be a more accurate way to do this. And we're going to pass in the paper. Okay, and then on the other hand, we have a loop for the goblet. So let's say while, this would be a really poor way to do this. But let's say we have a way to get the time. Basically, we need a timeout. We need something that checks every so often. So let's say we're going to set a timeout. No. Yeah, I guess that's how we do it. I guess that is how we would do it. We'd set an interval. I don't actually want to go through writing out all of this code, but maybe I should. Maybe I should, just so we've got it. We'll call this a timer. I think that might be appropriate. And it might be also appropriate to pull this over into JavaScript. So let me grab this real quick. Let me actually go into goblet.js, because I'll just put this in JavaScript there. We get some highlighting that way. Makes it a little easier to read. Okay, so if I remember this correctly, it is function first and then timer. So let's say we want to check every, so this is going to run for 5 minutes. Let's say we want to check every 5 seconds. And we'll do our start is equal to date.now. This might be a good way to go about it. So we're going to set a start time. Once it's started, it's going to go for 5 minutes. I guess actually, no, we don't even need to do that. We can just go straight to, this is kind of a weird way to do it because I picked a contrived example. But we could actually put the timeout to be 5 times 60 times 1000. And this would not work in a multi-threaded application, but it'll work in JavaScript. So I'm going to set, what was it? If expired equals false. And we'll say at the end of 5 minutes, expired is equal to true. And then we'll have a function put in goblet, because that's what we talked about here. And we won't do a while loop in this case. So the way that I wrote it out was kind of like a while loop, but let me explain why that wouldn't work. So if I say accept entries until deadline, so that's a loop. I'm going to do something until something. So that is a loop. But if I were to say accept entries until deadline, well, that actually doesn't make sense in programming, because basically what that would mean is I would have to check, is there something to submit? Is there something to submit? Is there something to submit? And this would be this would lock up the program because it would just be checking something over and over again without any time boundary in between it. So instead, this actually would need to be more of an event. So when the put in Goblet function is called, this is essentially the event. So we've got a put in Goblet. Then we take our, we would be receiving the paper here, and we would need to check first if expired, then return. So we just don't, or we could throw an error or something, but we're not gonna, let's say we throw new error, deadline expired. Sure, we'll throw an error for example's sake. And then what else do we need to do? So we need to handle the deadline condition for each paper submitted, get student record for name on paper. Okay, so every time this function is called, we're going to get the student name. So let's say that we'd have to have some collection of students, which we have not defined, but here we'll go. Let's say we've got Harry Potter, of course. I'm just going to call him Harry. And I don't remember the names of all the other ones, as it were. But he's got an age, and he's only 15 or whatever. So he'd actually get rejected. And then we'll just go with Sally is age 18, and George is age 19, and Stephen is age 17 here. And then they maybe have some school. So we've got Hogwarts. I don't want to fill all this out, but you get the idea, hopefully. Okay, so then we've got something representing our students. And it's good to put mock data in these sorts of situations, like we're doing here, just to kind of have something to think around. Hogwarts. I think I meant Hogwarts there. Okay, so let's go back down. Sorry for that detour. So we need to check if the time is expired, then we're gonna throw rejection that deadline is expired. And then we need to find a way to get the student record. I'm not gonna write this function, but we're just gonna say that we're gonna get student. We're gonna pass the student name, and we'll get back a student. All right. So get student record. We got a student record, and then if student.age less than 17, we'll throw new error, and we'll say underage. And then likewise, we could say if student.school, we could say schools includes. There's an include function on arrays. So if the school does not include, this is kind of, a lot of things in programming are reversed the way you think about them. So the student school there's a list of schools, Hogwarts and the other places. Does that list include the student school? So if this is just a list of strings, and the school name is a string, then this works out. So we say unapproved school. Great. And then otherwise, we needed to have a pile. So we needed to have some piles here. So we could have some piles, and one pile could be the Hogwarts pile. All right, there we go. So we'll do piles, student.school.push to add on to the array, paper. There we go. So that way as long as the schools are in the approved list, those will get through. And so now we've pretty much handled this. I did have to convert it to an event type system rather than a function system, but we've got it handled. So we can get rid of that. And then, okay, we have the otherwise. So this is really just, this would need to be a different type of event. So when the timer goes off, then we can say that this is expired, and we could call a function choose student. That's how we could handle that. So we've got a function choose student. And now we translate this, what we wrote on paper, into code for each pile of school students. So we had some piles here. So piles dot for each. And then we've got a pile. So the pile could be, oh, this is not an array. This is a object. So we could do, I mean, obviously you wouldn't know all of the different semantics. I'm programming in JavaScript, and you might be programming in something else. But the point is, you first need to know what you're trying to accomplish in English, and then you can go back and try to figure it out. So I've got some piles. The piles are a map. And so I need to go over, in some languages you can do for over maps. In JavaScript, I like to use object.keys, which basically says give me all the names of the keys. So let's say that the other one was called Bellevue. That's probably not even the right way to spell Bellevue. And then there was some other one, I don't remember the names of any of them. But for each pile, we want to shuffle the pile. So there's actually not a shuffle method in JavaScript, but I'm going to go ahead and pretend that there is. We could Google and find one. Fisher-Yates shuffle is ideal for simple arrays like this. So we could shuffle the pile. Actually, we don't even need to shuffle the pile. I said that we would shuffle the pile and we'd pick a student's paper at random, but that's what we do in real life, is we just shake up the bag. We could actually take the length of the pile. Let's say pile.length. So var the last number, because arrays are 0 indexed. So if I have an array of 2 things, they are numbered 0 and 1. So the length of the array would be 2, but the last item, the last index in the array would be 1. So we do a -1 here, so that would give us the last. And we could use math.random to give us a number between 0 and last, if I remember that correctly. Let me actually open that up here and try it out real quick. Math dot, is it random? Yeah, and then I can go between 0. Oh. Okay, no, that doesn't give us a range. I was thinking in Go. Okay, that gives us, oh, that's okay, we'll go with it. So you can, and math.random is not the right thing to use in every language. You have to consider security considerations anytime you want something that's truly random. Shuffle is actually more secure because it will work even with, this is kind of a weird thing, but a Knuth-Fisher shuffle, or Fisher-Yates shuffle, Donald Knuth/Fisher-Yates shuffle. Very simple. It's like 5 lines long. It's not something I know off the top of my head, but it's something you can easily Google and copy and paste for any language. Even if you give it an insecure random seed, it will give you a more, not perfectly secure, you still need to have secure random seeds, but it will come out with a secure, not secure, a balanced shuffle, which is kind of an interesting concept, but a little bit advanced. Sorry for bringing that up a little early. Anyway, so I did this wrong. What we do is, it ends up being, again, I shouldn't have gone into real code because there's too many things that have to be explained. My real point was just, we want to start in English and try to figure out what it is we're trying to do from there. But because I am doing this out in code, we want to, math.random is going to come up with something between 0 and 1. You can think of this between 0% and 100%. And so if we multiply it by the last number, if it is 100% or close to 100%, and we do a math.round on it, then it will be that last number. So if the last number, if the array length was 5, then if we come out with 0.97, something, 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 and we round that, that would give us 5. So this gives us the full number range. If it comes out with 0.1, then we multiply that, it would round down, you know. So anyway, we could just take something out of the pile that we could do var chosen equals here. Whoops. We could create a list of chosen, and then we could just put our chosen ones, or we could take something from the pile at random, and then we can put in the chosen one. Okay, so do we do that? For each pile of school students, pick the paper at random, spit out chosen paper. And so that's essentially what we've done here, is we've taken all the papers, and then we could either spit them out right there instead of putting them into the list, or we could return the list. We could have some other function that is an event to hand off a student. And one of the mistakes that early developers make, and even older developers, is modern programming is very much like the real world. The real world does not happen in a line-by-line scenario. The real world happens in events. You walk up to the counter, you put the food on the counter, the food gets scanned into the counter. Meanwhile, there's another counter where other food is being scanned in. And you might, while you're waiting for the food to be scanned in at the counter, you might do something else. You might go look at the end of the aisle, look at the soda, and you might grab a soda. So in real life, you have many different components that are doing many things at the same time. If you just look at one tiny component and say, well, what's happening? Well, their items are being scanned into the grocery store. But in reality, no. One thing that's happening is a person is looking for a soda. Another thing that's happening is that some items are being scanned in. Another thing that's happening is that there are 4 other aisles where items are being scanned in. And this is how programming works too. We have to be able to think about things as events, that when one event happens, it spawns another event. A lot of times, a lot of ways that people will teach programming, which is just absolutely not a good way to go about it, is that they try to fit everything into the system of loops to try to, I guess, dumb it down. But in reality, this is more confusing, because as you saw with what I was doing, even when I was thinking about it in English, I was kind of tripping myself up trying to think about just a process that I could write down, because in reality, these events are happening in different times. So keep that in mind. When you are doing a type of interview question, the interview questions almost never deal with events that would be happening. The interview questions are almost always about a single logical process that happens beginning to end without any respect to any other process that would be happening at the same time. But in real world applications, I mean, think about when you use Gmail, for example. Just think, just take a look at the way that you see things and write down on paper what you think might be going on, but also think about how many things are going on at a time. You check your Gmail. You're reading a message. Meanwhile, a notification comes in to let you know that you have a new email, or you're on Facebook. And as you're scrolling on Facebook, new things are popping up, but there's also ads are appearing in the side. So when you think about programming, realize that there are almost always, just like in real life, multiple things happening at the same time. You're in the grocery store, the kid's running around, you're trying to get a soda, somebody's trying to put your stuff in the bags, manager's coming over to help with an item that won't scan. All of these things are happening at the same time, and if we oversimplify the process, you miss out on the experience of understanding that programming models after the real world, because we're trying to accomplish, oftentimes the digital world is trying to accomplish similar things. Anyway, so a little bit of a tangent there, but I hope that this was useful for you. If it was, go ahead and give it a thumbs up. And if you have any comments, questions, or suggestions, please leave them in the comments. I would love to know how this was helpful, or how you think it could be more helpful. And I will catch you tomorrow or next time or sometime. You have a good night. The best night ever, in fact, if you may. And I will catch you later. Adios. Oh, come on now.